Okay, so now we're asked to use our data set to compute z-scores. Okay, so we have data here. We're given z-score or data value. We want to find the z-score. So remember, the process for z-score is always just to take your data value minus the mean divided by your standard deviation. Okay. So we want to find the z-score for 60. So the mean, they tell us, was 80. The standard deviation here is 10. So we work that out. 60 minus 80 would be negative 20 divided by 10 would give us a z-score of minus 2 for part A. For part B, we have a data value of 95. So 95 minus the mean, which is 80, divided by 10 would give us a z-score of 1.5. And then finally, the last question is, find the z-score if x is 35. So we would do 35 minus the mean, which is 80, divided by the standard deviation, which is 10. That would give me negative 45 divided by 10 will give me a z-score of negative 4.5. Okay. And then finally, the last question, or second to last question, the last question on the sample test, but we will do one final question. That is that we're dealing here with a situation where we know the mean, we know the standard deviation, and we're asked to use our chart to figure out the likelihood, the percent of people that fall in some range. So in part A, we're looking here at a, we want to know the percent that fall between 500 and 600. So we would first compute the z-score for both. So for 500, it'd be that value minus the mean divided by our standard deviation. So we'd actually get a z-score of 0 for 500. In fact, anytime you look at the z-score for the mean, it will actually be 0. And then we do the same thing for 600. So 600 minus the mean, which is 500, divided by the standard deviation of 100. We get a z-score of 1. Now, once we have those values, okay, we need to then go and look at our chart, which again is part of your test. The chart again will be part of your test. So very last page of your test. Just need to give it a second so it'll load up here. Very last page of your test. We have this chart. So we'd look up the z value for the biggest one and then the smallest one as well. So we look up 1, we see that that's 84.13. We look up the z-score for 0, we see that that's 50. And then we subtract them. And we subtract the two answers. So 84.13 minus 50 gives us 34.13%. So about a third, a little bit more than a third, falls between 500 and 600. Okay. All right. So the second question here wants the percent below 570. So once again, we compute the z-score for our data value. And so we're going to get a z-score of 0.7. And then we're going to go to our chart, look up the z-score of 0.7. You see, there it is, 75.8. 75.8. Now, here, since it's the percent below, and that's what the chart actually tells us, that's our answer. We're done the problem. 75.8% of people that take the SAT test on a particular part, whether it's the reading or the math, score below 570. Score below 570. Continue on, we have two other questions here. We want the percent above 460. Above 460, so we first compute the z-score. 460 minus the mean, 500, divided by 100. So we get a z-score of negative 0.4. And so once again, we would go to our chart once we have our z-score. Look up negative 0.4. We get 34.46. And because we're doing above, we have to take that answer away from 100. We have to take that answer away from 100. So it's 34.46. And so we take that away from 100 to get our answer. So it turns out 65.54. 65.54%. So about 2/3 of people that take the SAT test score above 460. Okay? And then finally, the last one we had here is another between. We want between 450 and 650. So we would once again compute the z-score for each. So for 450, 450 minus 500, all divided by 100, we'd get a z-score of negative 0.5. And we go up to 650. Z would be 650 minus 500 divided by 100. And we'll get a z-score of 1.5. And then once we have our data values, we once again go to our chart and look them up. So negative 0.5 be 30.85. Make note of that. Negative 0.5 be 30.85. And we come over here, 1.5 is 93.32. And remember to do the between. What we need to do is take and just like we did on part A, is just subtract those two answers. So subtract those two answers. 93.32 minus 30.85. And once again, we just pop onto a calculator for that. 93.32 minus 30.85. They find out 62.47%. Fall between a score of 450 and a score of 650. Okay. All right. Final thing you're going to run into on your test is going to be percent or margin of error. So an example might be that you had a survey where candidate A got 52%, candidate B got, let's say, 46%. Maybe we say that we surveyed 500 people, and so we're asked to find the margin of error. Remember, margin of error is always 1 over the square root of the number surveyed. So on my calculator here, I can do 1 divided by square root of 500. So punch that in. 1 divided by square root of 500. And I get 0.0447. Usually you like to take this out to 4 places here, because we're going to convert that to a percentage by moving the 2 places. 4.47% is my margin of error. And then the final thing is, what would the range then be for the leading candidate? So it would be 52 minus that. So work that out. 47.53. To 52 plus that. That one's a little easier. That's just 56.47%. So most likely the actual percentage for the leading candidate is somewhere between 47.5 to 56.5, roughly. So that's margin of error. Just remember, it's always 1 over the square root of the thing. Number of things. And that is your margin of error. Okay, so we've gone through everything on the sample test, including the things that weren't on the sample test, which was the margin of error, which you will have on your test. Again, something very similar to this idea here. And the other thing was the mid-range, which you'll be asked on one of the questions as well. Remember, the mid-range is just the average of the two. Please be careful not to confuse mid-range with the actual range. Range, we subtract the two. Mid-range, we average the two, high and low. Careful with that. Hopefully this will help you as you prepare for your exam. Good luck.